No? Cool, thank you.
No worries. Hi everyone, welcome. I think we're ready to start. Thank you so much for coming. Welcome to February LondonGophers. Thank you for our hosts. Thank you to our hosts tonight, Deliveroo, as well as our new sponsor, Tyke and Utility Warehouse. Here's the plan for tonight. So we're going to have Alice, Grant, Dom, and Ilan speaking for tonight, as well as the usual breaks and conundrums. After the meetup, we're going to have a social at the Oyster Shed. It's just a few minutes, it's just around the corner from here, a few minutes away, so come and join us for the social. A few words about health and safety, and I'll hand over to Antonio.
Yes, I do the fun part. Hi everyone. So we want to keep you healthy and safe. So there is no fire alarm planned at all. So if something happens, if you hear something, that's a real problem. So we want to go towards so exits are towards the entrance where we came from, or where the toilets are on those two sides. You can see I'm not a front-end engineer from the quality of my drawing there, but I hope that's clear. So on those two sides there are toilets and also fire exits. And yeah, if you have anything to ask, find me or someone with the Till lanyard, and we will be able to help you if you have any question for us. Thank you very much and enjoy the night. I'm gonna hand over to Tom from Deliveroo, who's gonna give an introduction about us.
Hello everyone, thank you very much for coming. My name's Tom. As it says there, I'm the Director of Engineering for Delivery. Delivery is the group that gets the food from A to B, so it's everything to do with the riders, everything to do with the navigation systems, the payment systems, anything that allows riders to find, access and get paid for work, as well as the logistics function itself, the thing that actually does the dispatch and works out what is the best rider to assign to which order. A few details about Deliveroo. We've been around not a long time. We're still a startup despite the fantastic place we are here. We're in 30 markets, an obscene amount of cities, and we have a really sort of significant tech team, mostly based in London, but also in Edinburgh and New York as well. We use Go across all of our teams. So I can tell you anything that you want to know about delivery, but your food tonight was made by Go services that work in restaurants and delivery and places like the restaurant list, which show you the wonderful restaurants that you can order on the platform. So yeah, why are you here today? Well, Deliveroo absolutely loves the Go community. We're big users of Go at Deliveroo, and our engineers are involved in the community, in organising the community and contributing back to open source as well. We've been using Go probably for about the last 3 years. It's one of our now blessed languages, and it's something that is sort of one of the primary languages that we use throughout the whole company. Like I said, the food tonight when you start your ordering journey, the first thing you see has been generated by Go services. It does candidate selection, ranking and relevance, and that shows you the places that you can order and the expected delivery times that it might take for that food to get to you. When it goes to the restaurants, the Go services actually allow the restaurants to find and manage their orders that they've got, and when it finally gets to the delivery network, the thing that does model serving and does expected delivery times and vehicle routing, so topological travel time models and things like that, that's all built using Go. Tonight we're actually running 2 meetups. We have Golang New York, where a couple of our engineers are speaking as well, and obviously here tonight. So I won't keep you any longer than that. You'll get to the main content, other than to say, of course we're hiring, we're looking for great engineers. We'd love you to come and join us and help get food delivered to hungry people. Thank you very much.
Thank you.
So now we have a small update for you about our sponsors. Throughout 2019, and especially towards the end of last year, we've had a lot of companies come to us and ask us if they can sponsor London Gophers. So the space became a little bit crowded, and we've taken the decision to start rotating our sponsors. So as you may know, for most of last year, we were held by 4 companies. We were held by Monzo, Bad, Vistus Recruitment, and Utility Warehouse. And unfortunately, we thought it was only fair that we start rotating the sponsors in and out to give other companies a chance to also come here and talk about themselves and let themselves be known. So we've decided to rotate Monzo, Bad, and Vistus out for now, and soon Utility Warehouse. Monzo will still host us a few times this year, but otherwise we've decided to rotate them out of the current pool for about 6 months, and we hope to see them again at some point. And the exciting news is that we have a bunch of new sponsors coming up. But before I introduce the first one, I would like all of you to give a big round of applause to all the past sponsors for helping us, for being the first ones to want to sponsor us in a sort of the official way, and for helping us for all of last year. Without them, we wouldn't be able to put on the events that we do at the scale that we do. All the money that they give us goes towards food and drinks and other bits and bobs that we need to pay for. So a big round of applause and a massive thank you. And now I'd like to invite Josh from Tyke, who will say a few words introducing them and who they are.
Thank you, Kat. Cool. Hey guys. So I'm Josh. I'm a consulting engineer at Tyke. Thank you very much for having us on as sponsors. Thank you, Kat, Antonio, Dom, and Paul, and all the rest of the people who run this meetup. I've been coming for about 3 years. It kicks ass. It's probably one of the best meetups that you get in London or anywhere else, frankly. And the passion that they put into it and the amount of own time they put into it is really important, and it's something that we kind of really associate with at Tyke. So when they said that there was opportunity for more sponsorship, we were like, hell yeah, let's get on it. So what is Tyke? Essentially, it's an API management platform built on an open source API gateway. Everything at Tyke is built with Go. It always has been built with Go, and it always will be. If anybody suggests to me that we use Rust instead, then they're out there. So, essentially, we started as an open source project about 5 years ago. Now we are basically connecting services all over the world. If you make a credit card transaction, if you book a hotel online, if you do any number of things, we're in the plumbing and we're making that thing happen for those companies. And it's all high traffic, it's real engineering problems, it's exciting stuff, and it's cool to work with on a day-to-day basis. So why do you care? I think we're all here kind of gathered around the same people. It's about supporting the meetup. They really are doing a great job. Also, we have a lot of really wicked stickers. We're proud of our mascot. Our designer is like super talented, and she does some great work. Most of them infringe on some kind of copyright, so if you can grab them in the back corner there, they might not be around forever. And if you're a lawyer for Disney, come get me. Of course, we're hiring. We're looking for back-end engineers. Everything's in Go. We're quite a small, tight-knit team. This was us about a year ago. We flew the whole company out to Thailand. We were about 25 people then. Next month, we are flying 75 of us to Bali for a week. And it will just continue to get more ridiculous from there, I hope. Also, people like me, solutions architects, technical architects, consulting engineers, but actually anyone who's talented, anyone who thinks they've got something to give, or if you think you want to make an impact in a company that's growing and is only going from strength to strength at the moment. You know, we're up against plucky little underdogs companies. I won't name them, but it rhymes with Blue Bull and Flamazon. And just to finish off, we've got a really cool initiative that we have just launched. So here at Tyke, I mentioned we started as a little open source project, and then we turn that commercial. You have a real problem, and you find a need for that. You fill that need, and then you go from there. So we are looking to try and support people like you. You people have great ideas. You're working 9 to 5, or even more if you work for some other companies, and you might have something that you want to try and support in your own time. So we're offering essentially micro grants. So we will give you free money towards whatever you think you need it for. So maybe it's server costs, maybe it's you want to do a bit of promotion and marketing, maybe it's Dom's pointing at his beer. But yeah, essentially you can just go to our website. We've got a tyke.io/fund. Just tell us a bit about yourself, what you're interested in doing, and essentially we could pay up to 500 quid towards it. And it's just those little things that hopefully push people over the edge to greatness, in my opinion. I'll be around at the break. I've got myself, I've got James, who's from our engineering team, so he's in with the thick of it. I'm a little detached these days. And if you want to have a look at the core open source project, it's on the GitHub link there. The website is tyke.io, and our recruitment human is a wonderful person called Michal. So if anybody, we basically accept unsolicited CVs at any time. Just tell us who you are, what you're excited about, what you want to be doing, and we will go with that. So thanks a lot.
So before we go into our first talk of the night, I'd like to point out, speaking of swag, we still have the posters and the postcards from the Go 10-year anniversary. They're in the same corner as the stickers, so it's that corner over there. Please grab as many as you want. There are no restrictions per person, and save Paul from having to lug them all around London to every single meetup. So please help yourself to the posters, postcards, stickers, and whatever you can find over there. So let's give it up to Ilan, who's going to talk to us about visualizing data that we know nothing about. He's somewhere around here. Are you all mic'd up and good to go?
Mic'd up.
Cool. Do we need to do a laptop swap?
Yes.
All right. I'll cause some sort of distractions while this happens.
Round of applause in the meantime.
Round of applause in the meantime.
That's the first one, the second one.
Yeah. Okay, and
The second one.
and then this.
In the other pocket. Sorry. Okay, can you all hear me?
Yep.
Yes? Okay. Okay, so I suppose we should just start. So what I'm going to be talking about is how we visualize data we know nothing about. And at the bottom there are two links you can find information about who I am. I've been in programming, engineering, team management for about 20 years. I've been using Go quite a lot for the last 1.5 to 2 years, and we're using Go primarily in my team at the moment. This project that I'm working on it's a side project that I worked on as part of stuff I've been studying, so it isn't related to any of the work I'm doing professionally. So let's go to the next slide. So what I'm going to go through today is why would you care about visualization? Just a quick review of what's important about visualization and why it's important to us, to the world. Then I'm going to talk a bit about the state of the art of where visualization is today, and then where the gap is with where we are with all the current tooling. Then there's been a lot of research, and it's ongoing. It's a current research problem, how we close various gaps with visualization. And I found an interesting paper that was written and published towards the end of 2019. And I then took that paper and I built a proof of concept. It's very, very simple proof of concept, but it demonstrates perhaps what is possible that's not currently being done in any visualization tools on the market today. And then I'm going to go into a questions session where we can delve deeper into any aspect of what I've spoken about, because in all the different parts there's endless information that you can just dig deeper and deeper into. So if there's interest and there's enough time at the end, When I finish speaking, I must keep an eye on my time, then we can dig deeper. Okay, so the first thing we're going to talk about is, or what I'm going to review with you, is why care about visualization. What's important about it, why we do it. And now really there's two, based on most of the research I read, there's two important things that we can get from visualized information. The one is knowledge gain. I think that one seems quite obvious. You can learn something you didn't know before. It's not that useful to look at some kind of image if it's telling you something you know already. It might be nice to say, hey, I know that, but it's not useful. It's not going to get you further than where you are right now. So we're looking at ways in which visualization adds value. So the one thing is knowledge gain. And the second piece is cognitive work. By cognitive work, I mean that your brain, your mind, the things you think about get engaged, get woken up. And you're looking at the image, and it's making you think. It's making you look at the data, hopefully in ways you haven't looked at it before. You see something that you wouldn't have seen, and you wouldn't have thought more about. It may not immediately give you any new knowledge, but it will lead you to thinking about things in a new way, which could lead to innovative behavior and new kinds of knowledge. One of the well-known thinkers around visualization is I don't know how his name is necessarily pronounced, but it's Van Wyk. And he speaks about how the human mind and the eyes work together, and that you can see something very, very quickly with your eyes when you look at an image that you would never see just looking at data or just looking at the written word, which you can probably see from this, because this is just words on the screen there. It's not a visualization of anything. The second point, I think, which I tried to emphasize earlier, is that the value of visualization isn't in learning something you know already. It's about building new ways of thinking and finding solutions or ideas or problems that you didn't even know about before. And then in terms of where we are today in the modern world, if we can automate ways of visualizing data in ways so it shows us something we haven't thought about before, then that's just a good for the individual, it's a good for the world, it's a good for society. So that's what Van Wyk had to say. And a second thinker, Colin Ware, stresses that the faster we can do this and the better that we can do this, it adds value. And then he cynically pointed out that most of this value has monetary value as well. So that's definite incentive for virtually everybody. So the problem that we have with getting visualization from data is, I think, quite neatly summed up in this mathematical equation that Colin Ware put in his book, which is one of the seminal works if you do want to learn about how the mind works when looking at images. And he points out that in order to use a visualization, this is the cost. The first part is how long it takes to learn how to use that visualization multiplied by the value of that specific user's time. Because time is probably the most expensive thing. And then that gets added to the time spent actually building that visualization multiplied by the value of that user's time. Now, there are a lot of skills involved at this point. There's the skill of the subject matter expert that actually knows that data in question. But it's more than that. It's also the skill of the people that are going to be building that visualization. It's understanding the database that the data is stored in. It's knowing what tables are. It's probably knowing what SQL is. I assume everybody here knows what SQL is. Maybe let's ask. So maybe with a show of hands, how many people here use SQL regularly? So that's not even every hand, although maybe some people just didn't raise their hands, but we're experts. And it took us time to learn that. And to use SQL well, that's not an easy thing. As people here who use SQL a lot probably know using it well is different from just using it. In terms of performance, in terms of maintainability, there's a significant amount of skill there. And SQL itself isn't enough for the visualization. It's just one of the skills you need. There are a lot more skills. So here I've got the first visualization in my slideshow, and this is a very famous one. It's from maybe one of the first works about visualization by a man named Edward Tufte. And what he has here are pictures of the United States of cancer incidents between 1950 and 1969 for females on the top and for males at the bottom. And then immediately, just with your eyes, you've probably picked up information already that's telling you stuff you didn't know before and making you think about stuff. For example, you can see in the top northeast, there's definitely something happening there because there's more cancer there. But you also notice, if you then start looking across it, you start noticing differences that start raising questions. For example, you can see that for males in certain areas, there's a higher prevalence of cancer than for females. So something is going on there that's not related to geography and related to what the men are doing and what the women aren't doing. And I think, but I can't remember definitively, that it was related to the mining and the mines that the men were working on in that part of the world where there was exposure to cancer-inducing agents. So immediately from this information, people can start doing things to make people's lives better that wouldn't have been obvious from before. Also, you start seeing hotspots which can start be triggering national-wide action. Similarly, with other kinds of things, a visualization like this is very, very helpful. So I hope I've managed to get across the importance and the value of visualization. So I'm now going to spend a minute or so on where we are with the current state of the art. Now, perhaps the two of the top visualization tools today are D3 and Tableau. And the top left on the slide, you can see some of the images you can produce with D3. I don't know, maybe a show of hands, how many people here have worked with D3? So a few people, less than half, I think. And D3 isn't trivial to use. You have to know a significant amount about how JavaScript works, but even that's not enough because D3 itself is a domain-specific language written within JavaScript. I think it's what's called a embedded domain-specific language, which means you're actually learning a second language within the first language in order to use it. And then once you've learned that language, being able to build professional images from it is a third stage. So that's a significant skill. Using D3 well, you don't get easily, and you don't achieve easily either. It takes months. I mean, you can get something that looks nice. You can go to open source libraries and you can copy and paste something someone's done before to get something quickly out the door. But to use it efficiently, effectively, and smartly is a skill. On the bottom left, I've got a bit of an image from Tableau. You can see there they've got a tool interface where someone who understands already the tables underlying the data needs to pull things, drag things, drop things, look at images. Now, if that person doesn't know the data as a subject matter expert, they're just looking probably for pretty pictures, or they're trying to find something that people already know in order to just give them back the information that they know already because of, I think, what's bias? That cognitive bias. People like seeing stuff they know already. So if you give people stuff they know already, then they're very happy with you. It's not value adding. And so I hope I've made clear that although the state of the art today is very beautiful, We can do things today that we couldn't do 20 years ago. There's a significant skill gap in between taking data and turning it into beautiful pictures that actually provide value. So I think that there's no way I can emphasize enough the amount of skill it takes to be able to do a good job of actually finding visual information within data and presenting it to people to show them stuff they didn't know before. So this is recent research that has come out of Imperial College and Birkbeck University, which are both London universities. Two professors there have been working together in researching how we can close that gap and try and automate useful visual information from databases, taking out the necessary skill that currently it requires. I've got a little picture there just to tell you that I'm going to delve deeper into this. You don't need to understand everything on the screen right now, but I do encourage you, I'm going to make these slides available, to come back later and to read through what's written on these slides and to think about it if this is the kind of thing that interests you. But essentially, the key piece of information in this slide is that there's certain patterns within data that can be seen to be represented within different kinds of visual representations that make sense for that kind of data. So if you can find those patterns in the data, you can automatically generate a visualization of that piece of information. What they do stress is that these are affordances, these are guides. It's for someone that understands the data to be able to look at it and go, this is interesting, and go deeper. And these other pieces of information that are visualized isn't that interesting. A simple example, I think, which is quite famous, is there's correlated data in Australia showing that the rise in shark attacks happens at the same time in which people buy more ice cream. And that would come up as something that is interesting for visualization, so you would get a graph for that. But an expert would be able to pick up that that's not that interesting and not go further with that. So again, this is from the slide. I'm going to dive deeper into this slide with one or two actual worked examples that hopefully will start ringing bells and start making sense. On the left-hand side, I have what are described by the research as visual schema patterns, visualization patterns. If you can find a pattern that looks like something called a basic entity, then you can then represent that as a bar chart, a calendar chart, a scatter diagram, a bubble chart, a chloropleth, or a word cloud, for example, depending on information, metadata that's stored about that basic entity. So what is a basic entity? Again, I will dig a bit deeper into the next example because I'm going to actually show worked examples of the basic entity and the weak entity. But before I do that, let me just revise it. So a basic entity you can think of as a table. A table is an entity. On the left-hand side, you've got attributes. So if you know databases and you know tables, each attribute is a column. And then on the right-hand side, you've got a K. K stands for key. So you've got key, attribute, and entity. So you have a key, perhaps country name, which is the exact example I'm going to show you. And you've got some attributes, perhaps population. And then immediately you could get a bar chart on the bottom, all the country names, and then different heights of bars for the population numbers for that country, for example. A weak entity is when you've got a compound key in which, for example, you've got a city in a country. So then you could then start seeing comparisons of, for example, population, which is the example I will work, showing how populations within cities have changed per country or per some other kind of example. And then, as you can see, that there are two entities. There's one compound key made up of K1 and K2, and the number of attributes down the left. I'm not going to dig too deeply into the other examples, because maybe I'm hoping that based on my explanation of the first two, you can understand that a one-to-many relationship, a many-to-many relationship, and what a reflexive relationship is. Each one of those could be represented by the different kinds of visualizations described on the right. I have referenced the paper at the bottom right, if people are interested in digging deeper. So I'm going to now work an example. How much time do I have left, just so I can time myself? 10 minutes. So what I'm going to take to work this example is something called the Mondial database. Now, probably none of you have heard of the Mondial database. A lot of us have heard of the Northwind database if you've been in programming for 20 years, because Northwind was the one that came as the example database with Access 97. Anyone here used Access 97? Maybe a show of hands? Yeah, so I spent years of my life with Access 97. I don't recommend it. You have to repair it on a frequent basis. There wasn't a button called Repair Database when it stopped working. And this is the schema of that database. Sorry, not that database. And then Oracle has one. I know they've got a customer database that people do a lot of examples with when learning how to use databases. So in academic circles, there's a database called the Mondial database that was produced by a German university from web scraping. In the appendix in my slides, there's an actual list of the source of the data. But essentially, it provides information about countries, the population of that country, the economy of that country, what continent it is in, information, geographical information about religion, about languages, about various different things. And I have produced a Postgres database that has all this information in it, that's running, I'll describe in a few seconds, the actual architecture, which is a microservice architecture running in Kubernetes. And on the left, this is me going execing into the Docker container, running in the Kubernetes environment, and listing all the tables. So what I'm trying to just make clear here, before I run the examples, is what the data is that we're going to be generating information from. So the assumption is, with this information, we should be able to automatically get visualizations that are interesting and that teach us something we didn't know before. Again, I'm going to go into the architecture in a minute or two's time, but it's a microservices architecture. Ignore Ghost and ignore Zulip. That's something I'm experimenting with at the moment. But there are 1, 2, 3, 4, it's 6 microservices all running together, which produce the prototype that demonstrates and actually works the research, which I'll actually demo for you live, so you'll see how it works. So, did the sound go? Okay, it's all good. Okay, so I'm going to do a quick live demo now because I've been talking a lot, and I don't know how dry it's been. So I'm hoping to maybe give you an example of what it actually looks like. Now, first of all, although I've been working in computing for 20 years, I work very hard to avoid the front end. I profess I don't know what's going on. I look confused. I start working on something else. I'm not a front-end expert. So excuse the fact that it's not so pretty. Just try and understand what I've done underneath it. So this is a live running example of implementing that research. So what I've done is I've got the database and I've matched patterns against it, and it's automatically generating all the visualizations down the left-hand side. Obviously, you can do clever things with drop-downs. I don't know how to use a drop-down, so I haven't done that. So for example, if I want to see, and again, it's not so clear what's going on there because the writing's really small, but this is a bar chart that's generated automatically using the visualization patterns from using the basic entity visualization pattern that I showed earlier and for country and population. So for example, that one that's really tall, that's China, and that's India, and then over here is the USA. So I don't know if people have always heard that China's got more people than the rest of the world, but it really, when I looked at this, I never realized how significant that was. Another interesting thing that I learned straight away when I looked at infant mortality is that something's really going on in Afghanistan. A lot of children are dying in Afghanistan. We should find out why. It seems to really be high. Another example are scatter charts or bubble charts. So here are some bubble charts. So here we can see, I think, employment versus agriculture is probably not that interesting. GDP versus unemployment. And then if you're studying the economy, this kind of thing might make sense to you. I don't know anything about the economy, so I don't know necessarily. But it shows you on a logarithmic scale as the GDP increases, what happens with unemployment. I think we can obviously see a curve going on there. You can see wealthier countries have less unemployment, and countries in which nobody's working isn't making that much money. So some of it's quite obvious. That's an obvious one, which is the one I showed you here. Some of the more pretty ones well, okay, let me show you this one, because this is the other worked example I'm going to show you in a few seconds. But this is population of cities. So you can see Shanghai is now the biggest city in the world, according to the data in this database. But interestingly, it wasn't then. There's been, over the last 20 years, Shanghai's population has gone up from when in the 1980s or 1990s, it wasn't the biggest in the world. And then another example is Istanbul. So Turkey's population has increased significantly. This stuff's interesting. When I play with this and I look at it, I'm learning stuff I didn't know before. So I believe it does work. But then at the bottom here, I've got one that I think is the prettiest, so I'll quickly show you some of them. So this is the chord graph that gets generated from many-to-many relationships. And this is borders between countries. So for example, if you look here with China, you can see all of its borders. Or if you go look at Syria, over here, where people are fleeing, you can see where they flee to, which is to Israel. Well, they can't get through to Israel. To Iraq, to I don't know all the letters there, but those are the countries they go to. Okay, so I hope that's maybe shown you what can be done. I know it's not pretty, but that's just D3, and I saw there's some people here that work with D3 a lot. You can do something very, very beautiful with D3 with this data very easily. So let me jump back to other way to the demo. So also, if you want to dig deeper into this, all the code is I've licensed it under the MIT license. So you can just go take it. You can contribute to it. I'm using Travis to deploy it, and all the containers are on Docker Hub. So this is the basic example. Again, I'm just showing the data it's coming from. So this is taking the data from the country table. So this is some of the country information. And this is the pattern it's matching against. So some of the metadata around that table. And this then I've exposed through a microservice that exposes it as CSV. So any data can be exposed as CSV. I've called it the simple microservice, simple query, because D3 works really well with CSV. So this way, D3 can just plug into it. And here's the example I mentioned before with China, India, and America with the population. The second example, again, I showed it a bit earlier, is the weak entity relationship. That's with the line charts when you've got compound keys. And you could produce other kinds of visualizations with this. I'm starting to move a bit faster because I think I'm running out of time. So the way this was built with microservices. I ran this on the cloud. I had to choose a cloud provider, so I tried AWS, I tried Azure, I tried Google Cloud, and in the end I used DigitalOcean because it's the cheapest, and I was paying for it. The others offer much more services, but they cost more, so it depends on what you want. I didn't need 3 availability regions. So Kubernetes I chose as the microservice orchestrator. I think it's won the game. Is anyone here using a microservice orchestrator that's not Kubernetes? 2 people. So you're behind the game. I don't know. Good luck. All the mind share is somewhere else. So I'd be careful there. What I did was I built, as I said, 6 microservices. I built the user interface you saw there. That's running as a microservice itself. The D3 images are running as a separate microservice. The list on the left-hand side that gives you the list of all the possible matches, that's a third microservice. There's a fourth microservice that turns the database table you saw into the CSV. And then this is one microservice. I put it in a square. And what it's done is it's taken all the data out of the entity relationship Postgres database, it's stored it in a semantic database as RDF triples. And that's what the query is running against, using something called Sparkle. Again, I'm not going to spend too much time now because we're running out of time. But at the bottom here, I have links. If you can use the slides. You can, for example, go and see this runs the one microservice by itself. This one runs the, if I can try click it, maybe the one at the bottom. This runs the matcher. So these are matches coming back via Sparkle query. This is a way of running the Sparkle query directly against the microservice running the graph database. So you can run this. It's just an example. But that query there is actually inside the service that does the matching for you. And then D3 itself, I'll go back out of space. D3 itself is a separate microservice that produces the image based on what you selected as the match. This is how the actual process happens, in which you extract the data out of the database, turn it into a graph database so that you can do the matching. How much time do I have left? A minute, so I'm not going to delve deeply into this. If you want to, I'm free for questions. You can come ask me. As I said, all information is available, and I am the only person with my name that exists in the world, so it's very easy to find me. I don't need to be on any fancy social media. You Google my name, you find me. End of story. I'm not going to do any more with the live demo. This is a sequence diagram. It actually shows how the whole process works and how you get from the dashboard. When you click on the dashboard, it runs a match, comes back with the possible matches, presents it on the left. You then choose a graph. It then goes and it gets the CSV data from the database. It provides it to the D3 microservice, which in returns the image and puts it on the screen. So I think I've got maybe 30 seconds for questions. I'm not sure. Any questions?
I think maybe you have to take questions during the break or in the social.
I'm free to take questions whenever anybody ever asks me questions, anytime from now till the end of time. So it doesn't just have to be then. Thank you. And I just want to give a special thanks to Paul for helping me with the presentation. Okay, thank you. Can I just pull this out? You want this thing?
We're just going to do a quick level change. Nice. So for those of you who are here for the first time, we're on social media, we're on Twitter, we're on Meetup, and you will know that we're here. We're also on Slack. We're hanging out with the hashtag London, a Slack channel or group, and we're also on YouTube. If you're subscribing to the YouTube channel, because then we put all the videos that we record here on the YouTube channel, so you can catch up later on. A few words about the LondonGophers study group. Bev, who normally runs it, is one of the organizers here. She's ill, so she couldn't come. But she's put these slides together for us. So the next meetup is on February the 26th. It's hosted by Engine. Check out the separate meetup group for this, LondonGophers study group. And they're also on Slack under London Study Group, if you want to ask any questions. I think this is a bit more about the LondonGophers study group. Is it? No, it's a Paul. Oh, right, so this is a new thing from Paul. First hack night in a while, Wednesday, 4th of March at Lush, Soho. We had a meetup there in December, so you might remember. Only 20 spots available. There is a long wait list. Please update your RSVPs because it's really important to make space for all the other people who can't Oh, there we go. Our usual JetBrains raffle, the keyword for tonight is tasty, so head over to this link, type in tasty, and then it will do some Twitter magic to notify us, and we'll just draw a random winner, and you'll get a free JetBrains license. A few conference updates. So GopherCon Europe 2020 is happening in Berlin in April, and we have a discount code with the keyword We Love Gophers. I can't remember how much the discount code is for. It's probably about 10 or 20%. So yeah, come along to Berlin if you're free. Similarly, .go is happening in March in Paris, and we also have a discount code for that. So actually, I'll jump to this one in a second. 10% off with discount code Go London. And we also want to encourage you to submit a lightning talk. The submissions page is now open. You can just give a 5-10 minute lightning talk and be on that amazing stage in the theater in Paris. And we're going to go straight into John's talk on what's new in Go 1.14.
No, they said I'm all right.
You need also this.
All right, fair enough.
You should know this.
I don't know anything. Which bit do you want to do? You hold that. I'll hold this.
I refresh the light.
Yeah, cool. All right, thank you very much, guys. So Google Slides doesn't auto-advance. I found this really annoying, so you guys are going to have to help me through this presentation. I've got 10 minutes, I've got 30 slides, that's 20 seconds per slide. The animation is working, so as this clock ticks down, I want you guys to help me by, when it gets down to 12 o'clock and it explodes, I want you all to shout go. So hopefully we can give it a test run now. Ta-da! Boom. Cool, so who am I? I'm Dom Green, I've got a yellow t-shirt on, so hopefully means I'm approachable. If not, I'm really sorry. You can get hold of me at Dom Green or mail@domgreen.com. I work for a company called Improbable and I've been doing Go for about 2 years. I'm not the most in-depth gopher, but hopefully I'll give a high level of... Yeah, thank you. So, honorary mention of Go 1.13 before we move on to 14. We didn't have a what's new in Go 1.13, so 2 things I'm going to call out. The modules improvements, lots of improvements for modules. We've got the Go private, so you'll be able to access private repos with modules, and Go proxy to be able to have your own proxy and therefore be able to access. Thanks. So next one is dealing with errors. In Go 1.13 we have this new thing called the unwrap method, which allows us to unwrap and wrap different errors. Here you can see that when you do fumped error F, you can wrap errors to return just a standard error rather than a specific type. Which also means that you can start using things like is and as in the language. So rather than doing the if error equals error not found, you can actually just say is it one of those errors. Similarly, you end up working like this, so that when you return from your package something like the error permission, you don't have to return it, you can just return a standard error. Thank you. So going on to Go 1.14, we're very nearly there, 94% of the way complete. We have a few outstanding bugs. The ones in red are actually blockers for release. This means that we're probably a couple of days away still, but there's lots of new things in the language. Over 500 issues closed already, so hopefully there's a lot of things to go through. Yeah. Oh, I turned it off. What did you guys do? That's actually, oh, okay. So first thing, damn it, this. Right, overlapping interfaces. The first really big thing, overlapping interfaces. Here you can see 2 interfaces in Go 1.13. What would this do? Does anybody know? Is the timer ticking? The timer's gone. All right. Okay, let's keep going. It would break. So having 2 things with fumped stringer, you can't do that because both have a string method. It starts timer again. Amazing. So they both have the string method underneath the interface. You can't because of duplicate method string. However, in Go 1.14, overlapping interfaces means that we can do this. So the language specification has changed from the fact that an interface T can have methods specified on it, and then you can embed another interface into it However, all the exported and non-exported methods from it would come apart from like you just saw there, because you can't have two methods with the same signature. However, the Go 114 is changing the language so that we can have this. It now says if you have two interfaces with the same method, as long as they match, you can actually create a union of those two interfaces to pull up into a single interface. This is a union, so it's kind of like that, all things from all of the underlying interfaces. So this is what overlapping interfaces looks like. We can actually do this now, and the program runs printing out hello playground. So we have a doggy, which is a mover and a barker, and this actually can have the string method, so you could just do doggy.string and this would compile. So this effectively what happens, you have the mover, the barker, the doggy. Doggy inherits a mover and barker, and you end up with this. So it's created a union of the two, and now you have a string method, you have a move method, and you have a bark method. So this actually comes in really useful, specifically with this kind of use case. However, let me just go back. If you have two things with different method signatures, so an int and a string, you won't be able to do it, it still will break. One of the things with Go 114 is the last release to support macOS with 32-bit release. If everyone's updated to Catalina, you'll find things like this. All your apps stop working because it's not 32-bit anymore. This really upset me. Other languages are doing the same, so we're not alone. So yeah, last release to support 32-bit Darwin. Vendoring. There's been updates to vendoring. With Go mod, if you have a vendor folder at your top level of your directory, it will default into vendored mode. This means that it will go through the packages that are in that folder and not end up with this weird world where you're using the modules file and the vendored folder. You're not doing very good. The other thing to go with Go mod is the fact that we now have a new flag that will allow us to stop doing things like that. That was using a tools file at the top of your repo, so that you could bring in with the mod things that you didn't have in your actual program but needed outside. So things like stringer is the example here. With the flag go mod file, you can then give a file name where you want to do this. So I would end up doing go mod, then mod file tools, and in there I would add stringer. I'd probably add some other things like the mocking library that we had before. So this allows you to have multiple mod files in the same repo and separate those out. The other things that adds Go mod, Go insecure, a lot like the Go private and the Go proxy that we saw in last release. More improvements basically for modular Go. This allows you to talk to an insecure package registry, module registry. I'm not sure quite why you would, but it's there. But yeah, use a secure one. The other thing, Go module can now support downloading from Subversion, because everyone uses Subversion, so why not add it as a supported, sorry if you do. But yeah, this hit us in a couple of projects because of other SVC repository type things, so Subversion is there now as well. And the other thing, defer. Defer, if you don't know, is a way to have things execute later in your program. So you set up a defer, and when the scope returns, you will call that defer method. Basically things for like closing files or closing connections. Defer in Go 114 has been improved, so the runtime has been kind of souped up. You can see this graph here, which I took off Twitter, showing that as the Go version has been released, the amount of time that it takes to actually invoke a defer. I think this is called basically inlining it a lot better when it compiles. Daniel Marty would know way more about this than me, but unfortunately you get me. The other thing with defer, Bartek from the Thanos project helped me do some benchmarking, and it shows that in his benchmarked example, he's saving 91% by the basic language upgrade. So yeah, thanks very much to Bartek. He's just here. Hey. So the defer, why is it really important that we speed up the defer? Things like this. You basically have a mutex where you want to act on something with the lock. If your defer is slow, then you end up slowing down other things that are also dependent on that lock. And here's a better example from the crypto TLS library in the, you can go. Now, asynchronous preemptibility of Go routines. This is apparently really important, but every time I tried to read this, I couldn't quite figure it out. It kind of made my head hurt. So if anyone in 20 seconds can tell me what Go routines now are asynchronously preemptible are, that would be great. If not, I'm just going to stand here and hope you all know more than me. So, yeah. Apparently, it really helps with deadlocking. That's all I got from the description, but if someone could tell me afterwards, I'd be really happy to know what it actually means. But yeah, I've got 20 seconds, so I kind of need to buffer some time. You can come and tell me in a minute. Thank you very much. So the other thing that we're adding to the library, we have a new package called map hash. It basically takes a number of bytes and will return a hash of those bytes. So you can do this for example, these three things end up returning the same thing. You can seed the hash so that every time you spin up a new Go routine, you Thank you. TLS is dropping support for SSL version 3. We're also, by default, going to be dropping SSL 3 and TLS 1.3 by default now. Before, in 1.13, you could turn it off with a Go debug environment variable. You can't anymore. You need to use a different way to do that. The other interesting one, I quite like this one, cleanup. So there's a new t.cleanup function in the testing package and the benchmark package. This allows you to much more efficiently clean up after running tests. And what it actually does is runs all the tests and subtests within that test and then cleans up. How does it do that? Well, at the minute to clean up tests, you'd probably do something a bit like this. You'd have a defer. However, now you can call t.cleanup and do it in the place. It's one of the reasons why it's really important. It's in context of what you're cleaning up. So rather than deferring, having it in context is quite nice. Go. Every 6 months, Go releases a new version. Go 1.15 proposal is already open. It's released in May 2020. Hopefully someone else can do this lightning talk next time in May. And yeah, there's a lot of proposals there already. Some really nice improvements. Go. It wouldn't be a Go talk without talking about Go 2.0. What's quite interesting is all the things that are coming into the language now in 1.13 and 1.14 are all about testing and exploring what Go 2 would be like. So for example, the versioning you saw in the modules in 1.13, better error handling you saw in 1.13 as well. Adding generics may come soon because you need to experiment with what it's like before Go 2. That's my nearly 30 slides in nearly 10 minutes. I am Dom Green, thank you very much. And any questions? So I think the lightning talk was supposed to be 15 minutes. I did 10, just so you can either ask or tell me about something in the language that's released in 1.14 that I didn't cover. So if anyone wants to grab a microphone, crowdsourcing it. So does anybody have something in 1.14 that I didn't cover that they thought was really exciting? Is it? When's it coming out? It should be out by the end of the month. It's apparently overdue. But yeah, to be released soon. Anyway, if you can tell me what the preemptible async Go routines is later, that'd be great. Thank you. Thank you very much, everyone.
Gophers in New York. As Tom from Deliveroo mentioned at the start, there's a meetup happening at the same time, well, not at the same time zones, but over there today. So Antonio's going to just point his phone, and if you could all wave for about 3 seconds, 5 seconds, and just say hello. Hello. Antonio, say stop.
It's good, thank you.
It's good. Thank you, everyone. So that was thing number one that I was supposed to do. Thing number two is that I'd really like to encourage everyone to stay after the break for the TensorFlow talk. It's really, really good, so please make sure to stay. We will have you here, out of here by 9 p.m., I promise, because we have to leave this space by 9 p.m., so we won't be running late. Next announcement, there will be donuts during the break, and they will be along this ledge, so help yourself. And then the fourth and final announcement before we go into the break is the Go Conundrum. What is wrong with this refactor? You have the before and the after, so we'll leave this up on the slides for the break, so have a think and prep your answers. How long is the break? 5 10 minutes? Yeah, see you here in about 5 minutes. I forgot to mention that all the donuts are vegan, so everyone can have a donut.
I think everyone is mostly on the other side.
Actually, I'll give you a second to sit down. 1 minute to sit down if you're interested in the conundrum.
Maybe you should have like some, at least once per 2 weeks, right? A supporting day.
How are we doing on time? I'll keep it very good. Okay, we're going to start. So, for anyone, just to clarify a couple of points here. The refactor, I intended to rename the function here. So that's not what's wrong with it. I intended as well to change the parameters type. So that was intentional as well. So does anybody else? I can see 1, 2, 3 hands there. 4 hands. Okay, great. I haven't got a mic I can throw. Actually, so I'm going to come over this way. Step right here. And go.
So I think the second question you're now getting pointed to a copy of what is in the list from what is rather the actual item in the list. So that's not necessarily safe if it contains a mutex or anything like that.
Anyone else? Okay, so that's sort of it, but there's a slight problem. Anybody else? No? I'm just going to go on to the next. Oh. That's much closer. Okay, so the actual, what was just shouted out there is it always a copy of the last one? We'll just leave the copy bit in there, but is it always the last one? The last one, let's focus on that bit there. My favourite joke. So there's actually a missing break here, because of course you wouldn't write the for loop like this. If you find the match, you'd want to actually break out of the for loop in the first place. But this was an actual refactor where I made this mistake, and it's exactly the same catch as last month's conundrum, if anybody remembers that. It's about the scope of the variable I here. So obviously if you introduce the break there, things work as expected, right? You get the reference to the variable, and you could just do the return there, right? If you found the match, you didn't have to set it into the match variable at all. So the issue again is the scope of this I variable. It's outside of the loop, of the for loop's body there. So on every single iteration of the for loop, the address of I is the same. So by the time you're just setting the value from the item slice into the I variable, but on every single iteration, it is the same address. So if you find a match, yes, you set the match variable equal to the address of I, but because we continue to loop through the for loop, by the time you get to the end of the for loop, it is going to be whatever value was in there last, which is exactly what you said. So that's kind of, as we said, it's the missing break there. Of course you wouldn't write the code like this in the first place. But again, it's one of these bizarre situations where the scope of the I variable is somewhat bizarre. It's outside the body of the for loop. References there, and I'll include a Go Playground link as well for anyone who's interested. And now I will, just a quick reminder of the raffle, if anybody has not entered the raffle yet. No more phones. Tasty is the reference, 5, 4, 3, 2, 1, 0. 10% discount goes, .go. There's some great speakers at .go. Are you speaking at .go, Cam?
I'm not this year, no.
That was awkward. But you're speaking at GoPacon EU?
Yes.
Yes.
Yeah.
I got.
Last year.
I was getting mixed up with my conferences. And so now, can I hand over to our final speakers of the evening, Alice and Grant, who are going to talk to us about Go, Scratch, TensorFlow.
For anyone who noticed, that was a D3 graph, actually, in the back there. I'm Alice, and this is Grant, and we're software engineers at Ravelin, where we fight cybercrime.
Real heroes don't wear capes.
Love a good cape. It's great to be here at LondonGophers and Deliveroo. However, we've got a confession to make. In order to convince the organisers to give us a speaking slot, we tried to squeeze as many technical buzzwords into our submission as truthfully possible. And it worked. Now, this wasn't our actual submission, but more of a spiritual representation. But joking aside, at Ravelin, we are super excited about the current performance and future potential of machine learning with our vast stores of data. A few of us here in this room might even be training a model in a little black box as we speak. But then, what do you do with it? In a production environment at a commercial level, we are going to be wanting to hit it at speed and scale. So we want to ask it a lot of questions very quickly and probably from a lot of different locations. At this point, it's not just about how good the model is, it's about how easy we can talk to it. So, in the next 25 minutes or so, we're going to be looking at two ways of doing this. So first, it's an out-of-the-box solution called text-flow serving. And the second is using a language of choice method, which for us is Golang. And if that's not exciting enough, we have a t-shirt giveaway. For anyone who spots the code error. And that's code error in the slides, not in the live coding, because live coding. Right, now before we dive straight in, what does Ravelin do and how does it fit into all of this? So, at LondonGophers, with all of these amazing talks, you might be having a beer or 5, and the morning after, the night before, we're going to be craving something nutritious and delicious. At this point, of course, we will take out our favourite food delivery app, Deliveroo, and we'll select our menu, our choice, and it's at the point of checkout that Ravelin comes in. Via an API, we'll serve up one of 3 recommendations. We'll either say, yes, let this happy meal go through. 2, we should probably refuse this order. Or 3, block it because, frankly, they look fraudy. Now, if you're Deliveroo or Honest Burger, why should you care if someone's buying food from you using a stolen credit card? Well, you've given the food away. However, you don't get to keep the money. If the customer calls up their bank and says, this is a fraudy transaction, it's not the bank that pays them back out of the goodness of their hearts. It's the transaction's reversed out of your pocket as a merchant in what's called a chargeback. And then the bank then charge you a fee for the pleasure of that transaction. And here we're all thinking, banks are really nice people. And then, if this happens too often, the card scheme you're working with to take online payments, such as Visa or MasterCard, will start putting up the cost per transaction. And if it carries on for too long, they might not work with you at all, which is a bit of a kicker if you're an online e-commerce merchant. And then, of course, we've got angry customers who, rightly or wrongly, now associate you with fraud. I know I'm guilty of that. So these are all bad things. How do we stop these bad things from happening?
Yeah, so if we were to look at what a request might look like that comes from Deliveroo in a quick, simplified API sort of flow, we would get a request from API call from Deliveroo that says, this order's come in, it's for 12 beers, the customer's name is Grant, the payment is a company card, and the address is this place called Hotel Hangover. We then run a thing called feature extraction on it, and we convert 12 beers, and we say, well, we're pretty sure that's alcohol. This customer is a new person, we've never seen them before, no idea who they are, they could have just been invented. The payment, however, is a trusted card. We've seen these company cards before. They generally don't have chargebacks on them, and they generally don't run out of money either. And the address is in this dodgy postcode where, you know, scooters don't come back from, so you probably want to watch that. And then we pass this in to our machine learning model, and it'll come back and say, we should deny this order. Now, this is all very well, and we spoke through that in, 30 seconds or so. Except when you click place order, we don't want to be sitting there watching the spinny thing for like 30 seconds. So we need this to happen within a second, or even faster, depending on who you're working with. So, what are the ways of doing this and serving this model? So, an out-of-the-box solution is a thing from TensorFlow called TensorFlow Serving. You can get it from your local cloud provider, and essentially you upload a model, and they give you an HTTP endpoint to hit, and it scales, and it works, and you generally forget about it, except when it doesn't work. So, let's quickly have a look at what happens when it doesn't work, and also just how simple this really is to run. So if we look at the Docker file, so instead of running this on a cloud provider, to test this, we're just going to run it locally, because then we're not dealing with all the overhead of going to the cloud provider to serve out predictions and all that. We can just test it locally and forget about network traffic for now. So we just say from TensorFlow Serving, specify version, we give the model the name because it needs to know the model so that it gives you a special endpoint with the model name in it, and we copy the model from the folder into the models directory. And in 5 lines, which is actually 3 lines of Docker, we have a TensorFlow serving thing that is going to serve your model using HTTP. So, if we get to the right folder here, and we can build this with a simple Docker build. There we go, Docker build, and we just need to build the right version. TensorFlow serving, and we're just going to tag it as testing for now. We can see that this is going to not work at all because we need a dot. And we should have an image. We can also have a look at that, and that image size, while we're at it, images, how many images do you have, Alice? We can see there that it is about 223 megs. So the model in this case is actually about 200 megs on its own. So the overhead from TensorFlow serving is about 20 megs. So that's not too bad. Let's actually run this, Docker run, and it is running. Cool. So we also have a little Go script that is going to test this, example 1. And we'll get into the testing script a bit later, but we can just go run, test. Sorry, can everybody see this? Yeah, cool. Okay, and we're going to just make this because we don't, you'll see here that there's TensorFlow is quite verbose with this logging, and it doesn't actually log when you start predicting, so we can just make that a bit smaller and not care about it from now. Test.go. So what this is going to do is it generates requests all the time, and it basically hits the model with different requests, because if you keep on hitting it with the same one, then it kind of caches it, and you're not actually testing how fast the whole thing is. So it generates new requests every time, and we're measuring the response time and how many of those responses were successful. So if we start running this, we get a nice output. This is tested using a library called Vegeta, so Golang, very cool. And we can see there that we get some nice metrics out of this. And we'll stop before Alice's laptop crashes, because we don't want that to happen right now. So this is all very well and good. We can see we get a mean, a 99th. They're all successful, and we get a more or less successful rate. In the meantime, because this takes a while sometimes, I'm going to try and shut down this Docker image. Okay, and you'll see that I'm going to Control-C it, and it just hangs. And we'll leave that for a while.
Here's one we made earlier. This is what happens when we ran the images. So on the x-axis, we've got the requests per second, and on the y, we've got a response time in milliseconds. And we can see that it all goes swimmingly until we hit 10 requests per second, at which point it shoots up and CPU load builds up. This is awkward because it didn't actually tell us that it had broken. It didn't tell us, let alone tell us why it crashed. And right now, our customers are staring at the spinny thing.
Not ideal. Cool. So, At Ravlin, we use Go nearly exclusively. We can't quite convince the front end to switch. However, TensorFlow is written in C++. Go, for those of you that know, is not written in C++. So, luckily, TensorFlow provides some bindings. So we have a simple one-line import, and we can go import from GitHub, and we can now run TensorFlow code in Go, sort of, through the C bindings. So, if we would actually look at this. So what I'm going to show you now is 70 lines is all you need of Go code to run a TensorFlow model using Go. Okay, so let's go. The first,
Before we start taking photos of the code,
oh yeah.
it is available on GitHub, which we'll share in the link afterwards.
Yes, and the presentation is also available. Basically, it's all available. Relax. Okay, so we start off with package main, simple, some imports for logging in JSON and HTTP, then the all-important line, importing TensorFlow. Cool. Then we go into our main function. First thing first, we need to load the model. So we have this TensorFlow model, and we go tf.load_saved_model. You tell it what directory your model lives in, because the model consists of a couple of files. It's not just a single file. And there's this serving tag string thing. So you'll have to talk to your data scientist, because they'd like to set that to all types of strange things. But generally, just ask them, and they'll tell you what that is. You can also inspect the model to see what it is, but we won't get into that. We're even going to do error handling in 70 lines. So there we go. Panic if something goes wrong. And then we're also going to be good citizens and defer the close of this TensorFlow model. Then we're going to actually add an endpoint. Now, some of you might be asking, why do you have such a long, strange endpoint there? And this is just to make testing easier, because that's the endpoint that TensorFlow serves models on. So to use the same testing library and not to muck about with changing endpoints and stuff, we just serve it on the exact same endpoint, and then we don't have to change anything in our testing suite, because we're kind of lazy. Then what this handle function actually ends up doing is calling predict. And then last little bit of main, we listen and serve on port 8080. So if we look at predict, predict takes the response writer, the request, and the TensorFlow model as inputs. And we have this prediction data structure that we need to get from somewhere. Obviously, that's going to come from the request. We decode the body. Also, this is going to depend on what model it is. In this case, we're using the ResNet model, so it's a 2D map of your image, what's it called, color values. We decode that, and again, write out a 400. Maybe it should have been a 500 if we can't decode it. Then, another bit of TensorFlow stuff. Tensor is equal to a new tensor. So the TensorFlow representation of the data is slightly different to the Go representation. So luckily, TensorFlow provides us with a nice wrapper function that does this conversion for you. Unfortunately, at the moment, it's kind of doing a lot of allocations, but there's a pull request that's about to fix that from a colleague of mine. Because when models suddenly start using a lot of memory, it's problematic. Anyway. So we create the new tensor, again, write out a 400. If we can't do that, maybe that should have also been a 500. And finally, we're going to call calculate using the TensorFlow model and the tensor that we have just made. Okay. Right, we'll get to calculate shortly, but basically, from calculate, you get this S value, and we marshal that into your prediction, and then you're going to write out your prediction. Also with all your error handling. That's not the very important or very interesting stuff. So, question? No. Okay, calculate. Again, you're taking the model as input and the input tensor, and you're going to return your list of float32s, which is the model output, and you're going to say here, run is equal to TensorFlow session.run. Luckily, we don't have to keep like one session open. Once you've loaded the model, it keeps the session in memory, and you don't have to worry about all of that. You give this part is the input, and there's two important things here. The one is the input node name, which again, you're going to have to talk to the data scientists about, and they'll tell you that is the input node name, which also goes through some strange string transformations between Python and C, but anyway. And then you also have an input here, which you have just decoded from your incoming JSON. and you have an output. Again, you're going to need to know the node name that the output comes from, in this case, wide NN probability, and the sigmoid function of that. And as simple as that. You return any errors, and then you have to cast this output value into the value that you expect to get, which is, again, the TensorFlow representation and the Go representation are slightly different, so we have to put it back into a Go-friendly representation. And that is it in 73 lines. So, now what? Let us quickly look at what this then looks like in the Docker image that's actually going to build this. So, we start off relatively normal, and we say we have Ubuntu as builder. You need to install all types of things to get TensorFlow installed, and Go installed, and all of that. Install Go, unzip it, the whole lot. Pretty normal stuff. Set up a few environment variables. Then there's this part here. So there's a lib TensorFlow that you need to copy in, and this actually contains the C bindings that are also going to have to be in your Docker image to be able to run this. And you unzip those, and you configure the path for all of those, and you're also then finally going to do the build, and you're going to build this binary called, in this case, GOTF. So then we have also provided you with a nice script, and basically what you have to do is copy the C libraries that you need into a folder, because you're going to need those if you run this in a Scratch image. So we'll talk about Scratch just now, but essentially we then start from scratch and only copy in the libraries and the binary and the model, and we can run the model. So if we actually go and do this, coming back to our hanging Docker friend over here, it still hasn't exited. So this is another one of those things where you're running somebody else's Docker image and you don't actually know what's going on there. You pulled it from Docker Hub, and now it just hangs around. So unfortunately, what we have to do here is actually Docker, yes, and kill it, because that's the only way that we found to reliably get rid of it. Luckily, it dies quite easily then. Okay. Let's go to example 2, and we're going to example 2. We're going to build that long Docker file that I just showed you. Build, I think I've got this in history.
In case you were wondering, this is my laptop.
And we're going to call it test go in this case, just to show that it builds relatively quickly, but it's all been cached, so it's going to in this case. And we have a test go. That all works. Now, I want to run 2 of these together. So what we're going to do is run a TensorFlow serving version and the Go version next to each other, and then we can run the testing script and actually hit both of them to see the responses between both of them. So I've got a Docker compose file that just ups both of those 2 images that we've built, and this will also spit out a whole lot of output. But the important part now is that if we go to okay, and we go run testing test. We should once again, let's do that. Now we're going to have 2 sets of output. We're going to have one compiled version, which is the one we just built in Go, and we're going to have a serving version. And we can see that they're all kind of working. Okay, and because we are, again, testing the TensorFlow serving version, we don't want to crash Alice's laptop that's running the presentation. So, we can talk about the results.
Okay, we're looking at a similar graph, this time using a model that's actually we use for our clients. It's a lot smaller and a lot faster. So in the x-axis, we've got requests per second in the thousands, and in the y-axis, we've got response time, this time in microseconds. And the orange line is the TensorFlow serving, and the blue line is where we use our own Golang Scratch serving. You can see they've got a similar performance profile, so it takes a while to get started at the beginning. Goes fine, and then 3,000, 3,500, the CPU learns depends. You might be asking, why haven't we done it on the same model? And you're right, so we did. And actually, they're both similar performance at 10 requests per second. They both die.
So yeah, just to reiterate that, we've got a Go version and a TensorFlow serving version that are basically giving the exact same results.
So, what did we learn, actually? Well, Go, as you saw, was fairly simple. We did it in just over 70 lines of code. No C++ was learnt in the making of this presentation. It's pretty flexible. We are able to query the inputs for the model, so we can dynamically switch it in and out. It's fairly performant, as you saw, and what we saw, if our model, which sometimes take large inputs or outputs, if we G-zipped it, we can squeeze a little bit of performance by reducing the network traffic. If we wanted to add instrumentation, we just add a Prometheus endpoint. It's fairly straightforward, and with security...
Yeah, so we touched on it briefly, but how many people are using Scratch images to run their Go in production? Not enough, I think, is the answer. So essentially, Scratch means that you're starting with a completely blank Docker image again. So all of those dependencies that we installed with starting with Ubuntu, we can actually, in theory, a lot of those are security vulnerabilities at some point, and you have to monitor all the channels to know if there have been any security things that have happened with those. Whereas if we start from scratch and the only thing we're copying in is the Go binary, then the only security vulnerabilities we have to worry about are those in Go itself. So please use Scratch if at all possible. So you're starting from scratch. What that also means is that your image is a lot smaller. So that Ubuntu image, the from builder part in the beginning, that will come in at about 1.2 gigs or so, whereas I can show you, maybe we should just do that. If we go Docker images again, we can see that the one that we just built, TestGo, is 223. So it is exactly the same size as the TensorFlow serving version. Once again, we have about 200 megs of model files and 20 megs of actual code in there. So depending on your model size, your model size is the thing that determines the size of your image. But 200 megs is a whole lot smaller than 1.2 gigs. What this essentially means is that if you're running this in Kubernetes, your scaling is a whole lot easier because you're not having these huge images that are having to start up every time. You can also add health checks. So we can monitor queues on and GC and all types of things like that, and decide to make our health checks start failing for Kubernetes if there's a backup in the queue or something within the pod. We can also, in general, just have more control, decide when we want to scale this, decide when we want to start returning 500s, or when we want to return a 400, or when we want to, what metrics we want to give out. So, in conclusion, TensorFlow serving is really simple. There's 3 lines of Docker file, and you'll have something up and running in serving your model using HTTP. And it's performant, it's quick, and yeah, if that's going to work for you, then great.
Whereas Go, if I remember what all the emojis mean, is simple, flexible, performant, just as, gives you more control, scales easily, can add instrumentation, add health checks, and is slightly more secure. So which is better? Grand old, classic,
it really depends. So basically, what it comes down to is what's going to work for you. If you're a scrappy one-person startup and you need to get your model running yesterday, you're probably going to use TensorFlow serving, and you're probably going to put it on the cloud. And they'll do all the hard work for you. But at some point you might find that the cloud is too slow, or you don't like the way they handle errors, or you want to do something special with your inputs, or your inputs are too large and then your network overhead's too high. And so you need to do something yourself. And the point is there are options out there. You don't need to learn another language. You can do it all in Go. And it is just as fast. So, yeah. We are around. There's a link and QR code to presentation stuff and so on.
Yep. we're around. Also, are we hiring?
That depends. Did anybody see the error?
No. Or questions. Questions.
Any questions? Yeah.
We've got about probably at least 5 minutes for questions. So if you have questions, wave and Antonio will run with the mic. Over there. I can also help if anyone else has a question.
So I might have missed this, but did you figure out how to get it to serve more than 10 requests per second?
It depends on the model, is essentially the answer. If your inputs are too, it builds up a bit of a network backlog, and basically the incoming traffic is just too much for like one network endpoint to handle kind of thing. So essentially it ends up being scaling it. Or if you're, like in this case with Go, you can maybe zip the inputs and then you're sending in zip JSON instead of just JSON, and then you can reduce the network sort of load and you'll be able to serve more models, serve more predictions.
So no. Not with that model and not with the way we were doing it.
Yeah.
Cool, thanks.
Aren't there only serverless auto-scaling machine learning solutions? So you don't need to manage any infrastructure.
Yeah, so as I say, all the major cloud providers provide you with basically TensorFlow serving as a service. So you can upload your model and they take care of all of it. But
Yes, but you pay for the number of containers, and by serverless I mean...
No, so they charge you per prediction generally. Yeah, so you pay per prediction, but you don't have any sort of guarantee of how long that prediction is going to take or where it's run or things like that.
So, okay, but the response time was going up to over 10 seconds.
Yeah.
So it doesn't auto-scale.
Sorry, so that's running locally. If you run it on their thing, results vary. Yeah.
Yes. Okay, thank you.
Cool.
We had a question over here as well, Antonio, if you can just one step along.
Thank you. It was still about pricing, so do you have like a good cut by running, let's say, Kubernetes GCP and yourself compared to TensorFlow serving, for example?
We never actually ran it on the cloud because we found it was just too slow for us. So the stuff we're running in production at the moment, generally the prediction will take less than 3 milliseconds, whereas our average time for running it on any cloud provider was around 200 milliseconds. And like that's over our SLA. So we didn't, like, we started running it there, we were running it in what we call dark mode, so sort of testing models and stuff. We saw the response times and we had to make another plan.
Anybody else has any questions? I have a filler question. How the hell did you get this cool QR code? There's something cool. Coolest code I've ever seen. puremonkey.com. It's great. That is awesome. All right, any serious questions, anyone?
Also, how do I get my name at the start of my show?
So, if you didn't hear, how do I get the name of my name at the start of the shell prompt? Magic.
Because that was sick.
That was the best part of the presentation. Oh, there's a question over there. Just by the corner on your side.
Do you also write the models in Go, or do you write them in Python and then import them in Go to run them?
So we strongly encourage our data scientists to use as much Go as possible, but we haven't quite got them as far as doing the actually writing the models in Go. There's been a bit of work on that, and there's sort of more and more guides coming out on how to do it. But it depends a lot on the model type that you're doing, and you're going to end up defining a lot of these input nodes. And like one of our models I think we saw the other day had a couple of thousand different nodes, and you're going to have to sort of be essentially writing a lot of the stuff that's already written in Python again in Go. So your training might be slightly faster, but I don't think I see the point yet.
Anyone else? Any more questions?
We have a couple of t-shirts and socks and stuff if anybody wants to come and chat afterwards.
More swag! Oh, laptop went to sleep. No, sorry. LondonGophers on the Should we turn this one off? Or no? Okay. Alright, so that was the last talk of the evening. Thank you very much to Deliveroo for hosting us tonight, for all the food and drinks, and round of applause to Deliveroo. And thank you to Tyke, our new sponsor, as well as Utility Warehouse, for still supporting us this month. And we will see you next month at Monzo, March the 18th. Hope to see you there. Thank you for coming. Oh, I jumped the gun.